Okay, in this video we're going to look at functional groups and specifically some of the key terms around functional groups. So I'm going to start with a term we used earlier, that is homologous series. And some of the examples were alkanes, alkenes, alcohols, I think possibly esters as well we talked about. But these have all the same functional group. So alkanes are all carbon-carbon single bonds, alkenes have a carbon double bond in them, alcohols have an OH group on them. And how they all differ from each other is that we just add on for each successive one a CH2. So if we start with alkanes, we start with the number of carbons, we'll be able to see this. So if it's just got one carbon, an alkane is CH4. 2 carbons, the alkane becomes ethane, CH3CH3. Now this is added on 1 carbon and 2 more hydrogens, so CH2. Propane, again we've just inserted really CH2 in the centre here. Butane then adds another CH2 on. And we keep on going and going and going and going. And the same thing happens for alcohols, or for alkenes. I'll do an alcohol now. We'll start with methanol. So very similar basic formula to methane. It's just got an OH instead of one of H's. And then when it goes to ethanol, we get CH3, CH2, OH. So we've just added on a CH2. If we go to propanol, little mistake there, was not on purpose, but if we go to propanol, we add on a CH2, and so on and so forth. We keep on adding on CH2s to the homologous series. So functional groups are just a group of atoms that give a characteristic reaction generally to the compounds. So for instance, alcohols, their functional group is OH, and these OHs react in a certain way, so that becomes characteristic for all alcohols. So an alkane such as ethane will react differently to an alcohol like ethanol. There'll be slightly different reactions they undergo, but ethanol will have similar reactions to propanol. You see here, because they've got the same functional group. So the functional group, similar atoms, and they're responsible for their characteristic properties. Now, a term that comes up a lot is alkyls. And these are very much like alkanes, alkyls. They are just a hydrogen short on each alkane. So rather than methane, here we have methyl. Ethyl. I'll do propyl. And all that's happened to them is their methane, ethane and propane. They've just lost a hydrogen, and then because they lost a hydrogen, they can then bond to things, so they become side chains. So you get methyl side chain, ethyl side chain, propyl side chains. Next term we need to know about is aliphatic. Now, aliphatic are compounds that are in straight chains or branch chains. So long, nice straight chains like that, or it might be branched like this. They may even be cyclical. You'll get something a bit like that going on, or even just 5 in a circle. These are all aliphatic compounds, and nearly everything is aliphatic. What happens to make it aromatic, which is slightly different, is we get a special sort of 6-sided carbon ring appearing, which looks like this. It's got some double bonds in there. These are special types of double bonds we'll look at in second year. But when we get a compound that contains these, and lots of compounds do contain this benzene ring, we call it, then it becomes aromatic. Everything else is aliphatic. This two here, should use a different colour pen, they're aliphatic because they're not aromatic, but they're also alicyclic. I think I've spelled that right. So they're aliphatic compounds that form into ring structures. And finally, saturated and unsaturated compounds. So saturated just means that there are only single carbon bonds, single carbon bonds, and so the maximum number of hydrogens is attached to each carbon that we can in the chain. So this is saturated. We couldn't attach any more hydrogens if we wanted to. The maximum numbers attached. Unsaturated occurs when we have double bonds. So when double bonds occur, we've now, on this first carbon, only got 2 hydrogens. On this second carbon, we've only got 1 hydrogen, whereas before we could get 1 more on each. So this is unsaturated, because we haven't completely filled it as much as we can with hydrogens. And you could have a triple bond as well. That will be unsaturated. Or we saw earlier aromatic rings with those 3 double bonds in a hexagon. They're unsaturated because we could get more hydrogens on there. They are some more of the key terms you need for functional groups this time in organic chemistry.